Hi everyone. Today we're going to be talking about multiplying and factoring. And if you look at the two examples on this screen, it's kind of the two ideas we're going to be working with. You're going to see that rainbow, which reminds us of the distributive property. So the beginning of the lesson is going to feel kind of like a review of not only distributive property, but our exponent rules. And then the second part, we're basically going to back out of that idea. Factoring is sort of the opposite of the distributive property in this case. So that's what we're going to be talking about. This first part of Unit 8 is going to feel a lot of skill-based, so a lot of just computation. Just kind of bear with me. When we get to the second part, we'll start explaining where we're going to use this stuff. So the first thing we're going to do today is go and revisit distributive property. We're going to start by multiplying a monomial. Let's use some of our vocabulary from the last lesson, times a trinomial. It's a quadratic trinomial. And this guy is a linear monomial. When I multiply that 4x times the 2x squared, and you see me writing it right here, we're going to multiply the coefficients, 4 times 2. And since we are multiplying common bases, we're going to add the exponents, and the exponent is going to change. So we would have 8, and this is x to the first, times x to the second, would give us x to the third. We're going to take the 4x times the negative 3x. 4 times negative 3 is a negative 12. I'm going to write that as a minus 12. And x to the first times x to the first would be x to the second. And finally, don't forget the 4x times the 5. 4 times 5 is 20, and the x comes along for a ride. And you'll notice right here we have it in standard form in that the exponents are going down in their level of degree. So that is how we're going to start first, is just basically doing the distributive property. So I have a bunch of examples here, and what I would encourage you to do is, if you want to pause the video and just see what you can do right now, do the 5 problems and then come back and we'll catch to see if there are any questions. Okay guys, we're going to start with a basic distributive property here, 3 times a and 3 times 5. Don't forget you don't want to become a member of the I forgot to distribute to the second piece club, although many of you, if I remember correctly, were already in there, but it would be 3a plus 15, not 3a plus 5. Now that we've done our exponent rules, we can multiply a variable as part of what's going to distribute. So 2 times 3 would be 6. X times x, when we multiply common bases, we add the exponents. 1 plus 1 would give us a 6x squared. And then minus the 2x times 8 would be minus a 16x. We've got 2 distributive properties to do here, y times y plus y times 2, and then 3 times y plus 3 times 4. That's kind of an intermediary step because we're not quite done right now, because we have a pair of like terms. The 2y and the 3y, because they both have an exponent of 1, can be combined to become 5y, and we end up with a quadratic trinomial as our answer. Negative 2 times a negative 7 is going to give us a positive 14, and when we multiply common bases, we add the exponent, so 14p to the 5th. Negative 2 times positive 3 will give us a negative 6, or minus 6, and p squared times p is p to the 3rd. We're going to go back to that idea like number 3. We're going to multiply x to the 3rd times x, and x to the 3rd times the positive 2. And then the negative x times x to the 3rd will give us minus x to the 4th. And be really careful as we take that negative x times a negative 4, a negative times a negative will give us a plus 4x. We look to see, are there any like terms? There are. An x to the 4th and a negative x to the 4th are going to combine and make a 0 pair and go away. And we end up with 2x to the 3rd plus 4x. And notice it's written in standard form. So that's the distributive property and multiplying. That's the first part of today's lesson. Now let's take a look at the second part. So now, what if I give you the answer and you have to tell me what you multiplied in? It's called factoring. So when you factor a polynomial, it reverses that multiplication process. So we're first going to start to look and see what is the greatest common factor. So the GCF. So to factor out a monomial using the distributive property, it's helpful first to find what's called the GCF, the greatest common factor. So I'm going to look at this polynomial, and I'm looking for the greatest common factor. Now I'm going to show you, you might have remembered in past years sort of doing the factor trees, and I'm going to kind of show you that here, but then I'm going to give you the Woodruff way, the fast way to get there. So the first thing we need to do is find out the greatest common factor, and you really need to look at this as a product of prime numbers. Remember that a prime number is a number that can only have the pair of itself and 1 as factors to multiply. So 4 would be 2 times 2. 2 is a prime number. And then I write out the 3 factors of x. Now 12, you might say, oh, that's 4 times 3. But 4 is not prime. So 2 times 2 is 4 times 3. There's the 12 times the 2 factors of x. Finally, the 8 would be like 4 times 2, but the 4 is not prime, so 2 times 2 times 2, and there's the factor of x. And basically what you look is what do all 3 of the terms share, and you'll notice a 2 times 2 and an x, a 2 and 1x, a 2 and 2 and x. So each one of these terms has a 4x in it, and that would be the greatest common factor. Okay, I don't do it that way. So what I do is I look at the coefficients and I look for the biggest number that divides evenly into all of those, which would be the 4. And then I look at the variables. Do they all share the variable? And if they do, what's the smallest exponent? So the biggest number that divides into the coefficients would be 4, and the smallest power on the exponent would be x to the first. So the GCF would be 4x. So that's how I get there. So let's just look at these and find the GCF to start. So what I would do is I'd look at 15 and 21. The biggest number that divides into both of those would be 3. And since this guy doesn't have an x, we won't have a variable in the GCF. The GCF will only be the 3. If we look at the 25, the 5, and this negative 15, the biggest number that divides into all 3 would be a 5, and then they do all have an s. So what is the smallest exponent? It's s to the first, so they all have a common factor of 5s. Down at the bottom, I'm looking at the 4, the minus 2, the minus 6, they all are even. The biggest number would be a 2. And now I look, they do all share a variable b, and the smallest exponent would be to the first, so the GCF would be 2b. So the first step in factoring is to look at your polynomial and find the GCF. So what is this factoring? So the first thing I would do is look at this polynomial, find the GCF. The biggest number that divides into 4, 12, and negative 8 is 4. And if I look, they all have the variable of x. The smallest exponent is x to the first. So that would be my GCF. And I would write that out in front of a set of parentheses. I'm pulling it out. I'm not multiplying it in. It's like I'm pulling it out front. Now to fill in what I've left behind when I take out that factor of 4x, I kind of do an opposite and say 4x times what would give me 4x to the third. Well, the coefficient would be 4 times 1 to give me 4, and x times what would give me x to the third. I would need 2 factors of the x. So there is my 1x squared, and I made the coefficient of 1 the invisible 1. So now 4 times what gives me 12, and x times what gives me x squared. And it would be a 3x. So 4 times 3 is 12, and x times x gives me x squared. Minus 4 times what would give me that 8, and x times what would give me an x. And here it would just be that constant. Now, the cool thing about factoring is you can do the distributive property to check and see if you get that problem back. So 4x times x squared, does it equal 4x to the third? 4x times a positive 3x, does it equal 12x squared? And 4x times that negative 2, does it equal negative 8x? So you can check your answer and know whether you got it whenever you factor. So the answer when you factor this would be this guy right here. Kind of a funny thing that happens sometimes is students will do this process and then they'll box the answer as this over here. And I'm like, no, guys, that was the problem. Your answer is actually the 4x times the quantity x squared plus 3x minus 2. That's the factored form. So let's take another one together here. So I first look at these three terms and I say, what is the biggest number that divides into 3 and the negative 9 and the 15? And the answer would be 3. Look at my terms. They all have an x, so we will have a variable in our GCF, and the smallest exponent is to the 1, so again, it's just a 3x. So I'm going to write him out in front of the parentheses. 3x times what gives me 3x to the third? Well, I need 2 factors of x, and then that times that would give me the 3x to the third. 3x, there's my minus. Now 3x, I need a 3 to get the 9, and I need another x. So 3x times 3x would give me the 9x squared, and of course there's a minus in there. And then finally 3x times what would give me the 15x, and it would just be the number because the x is already in the GCF. And what I have boxed in here is your answer. That's the factored form, but you can check it by doing the distributive property to make sure you get back what you started with. But your answer, again, is in the red box. I have 3 problems here. They're asking you to factor those expressions. So here is the time where you should pause the video and see how you did in a minute, okay? Okay, guys, let's see. Our GCF, there is not a number, but there is a variable. So there's going to be 1 factor of s. S times s to the third would give me the s to the fourth, plus 4s squared, and then minus the 2. So you can just have a variable as your GCF. On the next one, I see the greatest factor would be 6, and the smallest exponent would be 2. So 6m squared is going to be my GCF. So this times what gives me 6m to the 6, and that would be an m to the 4th. Remember, when we multiply, we add the exponents. We're going to have a minus and a 4 to get the 24, and I need 2 factors of them. So again, when I multiply, I would add, and that would give me the 4. And then finally out here, it's kind of like, well, what do I multiply 6m squared to get it back again? Don't just leave a blank. It's a factor of 1. So again, as we do the distributive property, 6m to the 6 minus 24m to the 4th plus 6m squared. Okay, the next one, there is no number in my GCF, but there is a common factor of h, so h is going to be my GCF, and then we would multiply by negative 12h squared plus the 56h, and then plus the 7. So guys, that is multiplying monomials and then factoring out a monomial. I hope this makes sense for you all, and I'll talk to you soon. Thanks for your attention today, guys.